Okay, afternoon everybody. I hope it hasn't cleared out because there was word that someone was going to talk about structured product data, but I'm just thankful, Will, you didn't put me on after Jamie Johnson, because that's always a tough call. So I'm going to talk a little bit about product data, why I believe it's going to be the foundation for Digital Build Britain. A lot of the discussion actually about golden thread, about what manufacturers could do, I hope I'm going to cover some of that. So I'm going to walk through a little bit. First part will be just about what we've done, and just move on to then what the future is and what manufacturers hopefully should be able to achieve. Firstly, when people talk about data, a lot of people think just about this, about COBie data, about product type data. When I talk about product data, I'm talking about product type data, I'm talking about EPD data, I'm thinking about responsible sourcing, environmental information, pricing, linking in with e-commerce, production data. So what is was it you, I think it was, you were talking earlier about what's the cast number of that bolt that made that, yeah. So exactly that. We're looking at how can we trace our product data right back to what is the chemical composition of that cast number that went into that steel profile sheet, etc. And then obviously big performance data as well. Can we embed IoT technology into our products and start monitoring the in-use performance? That's my data picture. And although it's slightly ambitious, but that's what we need to work towards. The problem we have internally in Tata Steel, and the problem actually that a lot of people had, and Paul Surin touched on it earlier, is we all tend to be large construction product manufacturers. We are large siloed production units. We've got lots of different databases, lots of information sitting in lots of areas. When I came 3 years ago into Tata Steel to start looking at this, the task of trying to sort our data out and produce one overall product information management system was too large. We simply don't have the budget and the resource, even the size of Tata Steel, to start looking at quickly and simply one overarching product information system. So I said, well, I'll tell you what, let's have a phased system, a phased approach to our product data. So the first thing we did was we said, right, let's assign BIM champions to all of our technical managers, one person who's in charge of all the data at each site, and generate some product data sheets, generate some Revit objects, stick them on BIM object. Fantastic, job done, we can walk away. Or at least that's what I think quite a few manufacturers have done. So we did that first of all, and then we said, right, now we need to get to the detail of the product data. So we said, right, let's work with CodeBuilder, let's start to establish our product data templates, and we produced one massive master data sheet of all our product data. It was a huge Excel file, 2,500 product variations, about 850 attributes. That wasn't fun, but we did it. And then we worked with IBM, we made a database from it, and a back end for all of our BIM champions to log in and manage their data. And it's very clear, down to every attribute, who is responsible for the bit of data relevant to that product. We then built a front-end web tool, which I'm going to show you a little video on in a second, called the DNA Profiler. Because we split data from objects, we needed a way to generate objects on the fly, live from our data, so they're not stagnating in a database somewhere with objects packed full of data going out of date. And that whole issue of trusting data is all about that. If you've got data sitting in a live database and objects produced on the fly, and you can bring them together or separate them at any stage, you can start to produce managed content. And so we've done all that. We're now on the fun stage, which is we've got this great big database. What do we do with it? So we're starting to look at things like design and configuration tools, which I'll show you a very quick video on that. Two-way data models, digital twins, digital platforms, tagging, tracking products, etc. And then it's all about collaborating, developing, and linking. So this is our DNA Profiler.
Thanks to Tata Steel's new Bim Dna Profiler, building is a breeze. Engineers and architects can create and download custom BIM objects for their construction projects with more ease than ever before. Let's check it out. First, log in to access the Bim Dna Profiler. From the Profiler page, you can browse the product categories, apply filters from the left sidebar, and choose the product that fits your needs. Here, You can click and choose which parameters you'd like to include in your downloaded part, or select from the DNA Profiler's predefined data sets. Then click Next. From the 3D Product Configurator, you can customize the product to fit your design. In the window below, you can zoom, move, and rotate your part to preview it from different angles and detail levels to ensure that the product is right for your design. Once you're happy with your product, click the CAD Download tab. Under the CAD Download dropdown, you can choose from over 40 CAD and BIM format versions, including native Revit. You can also receive a free 3D PDF datasheet to share with team members who don't have CAD access. To finish, click Start Download. Now, you can test that product directly in your virtual design and get back to building. Thanks for watching. For more great parts, visit TataSteelDNAProfiler.com and check out PartSolutions.com to learn how your company can take customers from design to download in just seconds.
So the purpose of that really is to show that it is possible to have data and objects separated and to bring them together and to give that flexibility of object in any platform, data embedded or downloaded separately. So having done that and got over that hurdle of multi-platform, different data types, we then said, well, what else can we do? So we started working on a generative design tool. We started realizing we need to start working with other manufacturers as well. We have a lot of our products are in systems, which also were talked about earlier. Getting data for systems is tricky. You need to have configuration tools to bring in the individual components together, and then all of that data collectively can make the data for a system. So, for example, for us working with CNAF Insulation or Rockwool or Isova will be very useful for us linking their data in with ours so we can start to have built-up wall systems, as an example. So this is an example of design and configuration tool. This is a little video of the... can you keep my voice mic up? Thank you. So this is a little video of a tool that we've made. This is a demonstration in Revit. So as you'll see, there's a plugin. It's in, I think, 5 different CAD platforms. The first thing that user does is you drop a pin on a map as to where the construction site is. Once we know that, we know whether you're in Northern Europe, Southern Europe, and whether you're within a kilometre of the coast, which is vital for our warranty information. We also know what the wind load and snow load factors are for the zone that you've dropped it in. We can do then the full wind load calculation on the building and snow load. We can then also look to design the components for wind load, design check, and wind load and snow load. You can also generate all of those calculations from it. Then you can go in and you can start, this is an example of built-up wall systems. So you can choose from a couple of standard ones or you can build one bespoke. Once you've chosen what you want to build, you can then choose the color, the finish option for the outer profile. You would then be able to choose from put in your U value, choose from different insulation manufacturers. You can choose the color and profile shape for the internal liner. Then all the information is there for our guarantee system. We know whether you're Northern Southern Europe, we know where it is. We can give you options of changing finish or color to give you 30 or 40 years warranty period. Then it does moisture and thermal calculations, so you can enter which room you're in for kitchens, for example. It also does a full thermal bridging calc. And then once you've done all that, you can generate a report, which I assume will save some time for architects. One click, produce all the thermal calcs, all of the moisture calcs, and you can then export that into your documents. So having done all that, you can then bring your configured system into your preferred 3D CAD platform. You can also bring it; they're interchangeable. So even though you might prefer do it in Revit, you can bring it into Tekla, ArchiCAD, etc. So here he is choosing the curtain walling system, applying that design to that. You'll see it jump up in thickness, and then you have the color, the finish, the render, and all of that information straight in the model. So the developments, that's what we've done initially. The launch version of this, we will enable the window calcs to be done. We will also have a link between our product database and all of the components that are in that built-up wall system. They won't sit in the system, they'll sit in our database, which is a really key factor about this. So you can access via a click of a button on that object in the model, you can pull in whatever information you want directly from our database. It's not sitting in the model, it's sitting in our database, managed by us. You also have the ability to, just click a button, generate a technical specification. Currently, you have to come to us, contact us, wait roughly a week for that to be generated. You're able to produce it with a click of a button. We also will have user accounts, so you can log in and you can get an instant quotation, you can get a warranty, you can get a contract, all through there. Track your order, you can track the delivery of it, you can get proof of deliveries, declaration of performance, smart CE marking information, product provenance, warranty, all of that information accessed through the model itself directly from that component. And this is opening up quite a lot of opportunity for us. For example, when we were talking earlier about the golden thread, I know we don't play the full role by any means in the golden thread, but we can certainly facilitate it. Bringing that information back to a managed structured database from a manufacturer is really important. Particularly if, for example, you've brought in that system and we choose to stop producing a product. If we have it linked up, that's within 5 seconds that will update in the 3D CAD model, and it will generate an alert, which could be an email to the architect, the contractor, project manager, to let them know that that product is no longer manufactured by the manufacturer, and to prompt them to go back into the tool and to select a different product. The same if we change, for example, a performance characteristic, say the thermal transmittance is reduced, we would also generate an alert to let the designers know that something has changed in the data and need to refresh that and let them know what has changed. So that sort of thing is one way in which manufacturers can start to help drive this. When it comes to EPD data as well, we can start, I think, to drive behavioural change from contractors in terms of thinking about circular economy right from the off. So, for example, for steel manufacturers, we have to use the Module D given to us by World Steel, agreed, Module D. But Module D is the impact from reuse or recycling, the second life of the product. Now, if at the moment that's 5% likelihood of reuse, 5% likelihood of landfill, 90% likelihood of recycling. Now, if, for example, in the Netherlands where people are building regularly buildings that are designed to be reused, if they've gone to the effort to design it to be dismantleable, design it to be reused, they've asked for all the information to be linked through to those products, why should they have an impact, assuming only 5% likelihood of reuse? So we can actually start putting in, for example, 2 or 3 or 4 different Module D impact values and ask some simple questions in life cycle assessment models, such as, is the building going to be designed to be dismantled? In which case you can use a slightly better impact value for your EPD. For example. Same thing for, is the insulation going to be screwed or stuck to the plasterboard? That will impact whether it can be recycled or not. Is the concrete more than 98% chance it's going to be recycled rather than go to landfill? So all of these questions you can start to drive decision making based on reuse and being able to put in that live information from the manufacturers, just as an example. And then finally, where I think we can really make a difference. We talk about 4 golden enablers in Tata Steel. One is data accessibility, which I'll talk about, making our information available to you where you want it. Another one is database integration, so us linking back through for product provenance and also linking forwards into other companies' systems, so doing an integration, for example, into Bim object from our database. But then we're looking physical to digital, we're looking at putting an ID on every single one of our components, construction products. So having a QR code or some fixed laser etched or printed QR code, recording that GUID, that instance, and linking it at the point of order, placing an order through to a Bim component ID in the model. So we can give you real product information based on exactly the component at the point of placing that order. And then also monitoring, which is the incorporation of IoT technology. And so when you think about that and you think about this componentization driving construction platforms, This is a concept that we are wanting to build at the moment. We're working with some partners on building this. So if you have if you like, a virtual world of a manufacturer's product database linking via a mapping tool or a combination tool into plugins or 3D design and configuration tools into 3D models. If you then have a product with a QR code, at the point of placing that order, we can link to the commercial database, link to the product database, and place that, so we're linking right at the point of order the physical product to the 3D BIM model. If it's then scanned when it's in stock, scanned when it's dispatched, scanned when it's received on site, scanned when it's installed, all of that information at the component, the system level, you're building up systems, you're then installing systems, you're then building up a digital twin of the construction site in real time. And I think that can really help. Eventually that then becomes your digital as built model, which then you can use to control sort of ad maintenance, information, in-use performance data can all be linked to that, and then all of that information driving your possibility for reuse. All of that leads to product provenance and tracking, a whole load of export information for that data and where it could be utilized. And obviously, a big part of that for us, obviously, as well, is the feedback. So this provides us, having that information about what's happening going forward on the site allows us to be flexible on our manufacturing, can speed up, slow down, reappoint production systems. And I've really raced through that for you, but that's where we are. So just thinking about how components and component data can help to drive digital construction. Thank you.